This is Aranya Sheshalla. Welcome to EC Basic. Today in this class, we are going to learn about another important topic is multiple access protocols. See, what is meant by multiple access protocols? What is the use of these protocols in the network? We have to see. We have to know. Let us get into the topic. What is meant by multiple access protocol and what is the use? What are the functionality that performs in a network by using these protocols? Okay, so let us see multiple access protocols. The multiple access protocols was mainly introduced to reduce collision and crosstalk in the channel. To reduce collision and crosstalk in the channel. So what is meant by collision and what is meant by crosstalk? What is the problems or rise in the channels? The collision is one of the main problem in a particular channel. What is meant by that means whenever two or more users want to communicate or want to transmit data from source to destination by using a single dedicated path or single channel, the collision may occur. The collision will rise. How means whenever these two or more users release their frames in that particular channel, the frames will be collide. The frames will be collide. So in that case, the collision will rise. And crosstalk means the one frame data will be combined with the another frame data. So to reduce these type of situations, to reduce these type of situations, we introduce a multiple access protocols to reduce collision as well as crosstalk between the channels as well as crosstalk between the channels. So this is the main problem. Collision is the main problem because the channel, one particular channel will be accessed by more number of users, and all the users are releasing the data or communicating data at the same time. So in this, the channel, in that particular channel, all the frames are collide. All the frames are collide. The collision will rise in that particular situation. To reduce that type of situations, the data link layer introduces a multiple access protocols to reduce that collision and avoid crosstalk between the channels. Let us see what are the different type of multiple access protocols the data link layer is introduced. Let us see the diagram here. So these are the multiple access protocols. See, these multiple access protocols is divided into three types. Divided into three types. Random access protocols, controlled access protocols, channelization protocols. Random access protocols, controlled access protocols, channelization protocols. Mainly, we are discussing in this video about random access protocols. Random access protocols. See, the random access protocols means Aloha, CSMA, CSMA CD, CSMA CA. We have to talk about all these protocols now. Okay, let us get into that particular random access protocols. What is meant by random access protocols and what are the different type of protocols we have? We deeply discuss in that. Okay, see. So random access protocols. In this protocol, all the stations have a equal priority to send the data over a channel. So whatever the stations that connected to a particular network, whatever the stations that connected to a particular network, all stations have a equal priority to send data over a channel. Equal priority to use that channel to send data from source to destination from that channel. Okay, and random access protocol, one or more stations cannot depend on other stations. Here, different stations will be connected to one network, but there is no dependency on each and every station. But there is no dependency on each and every station. Okay, so there is no control. There is no control of each and every station. There is an independent stations. They connected to one network, that's all. Every station has an equal priority. Every station can send or communicate data from source to destination. But there is no dependency between each and every station, right? Depending on the channel's state, depending on this channel's state, Each station transmits the data frame. So here one dedicated path is assigned to all the stations. Here the more number of stations that communicate data at simultaneous manner means at that time two or more stations using that channel. So in that time only the collision will rise. Here the random access protocol tells depending upon the channel's state. Depending upon the channel state. Channel state means whether it is ideal or busy means it is an ideal state means it does not communicate nobody is sending frames in that particular channel or a different number of users are using that channel. We have to identify depending upon the channel state. Each station transmits the data frame, right? However, if more than one station sends the data over a channel, there may be a collision or data conflict occur. There may be a collision or data conflict occur. In this case, our particular data frame will be damaged. In that case, our particular data will be damaged. So, the we have a different type of random access protocols to avoid this type of collisions. So, nothing but an Aloha, CSMA, CSMA CD, CSMA CA. Let us get into the topic of an Aloha. What is meant by Aloha? So, Aloha is one of the type of random access protocol. It is specially designed for an wireless LAN. Wireless LAN. Okay, wireless LAN local area network. But also user and shared medium to transmit data. Here, Aloha is designed for wireless LAN as well as it is using in the wide LAN shared medium. It will act as an transmission medium to transfer the data from source to destination. So using this method, any station can transmit data across the network simultaneously when the data frame is available for transmission. Here, any station can transmit data across the network simultaneously. Means two or more stations want to send the data, want to communicate data with other stations, they can transmit the data frames at the time. But we have to follow the rules. We have to follow the rules. For that sake, the Aloha random access protocol has some rules. However, to transmit the data, we have to follow the each and every station or each and every user follow these rules before transmission of data. Before transmission of data. The first point, see, any station can transmit data to channel at any time. At any time, we can communicate data by using this channel. That is the first point. It does not require any carrier sensing. Carrier sense means before transmitting the data, you have to sense the channel. You have to check the state of the channel. Okay. So whether it is idle or busy, that is in carrier sensing, right? We have to discuss this carrier sensing CSMA in the later videos. Okay, it does not require any carrier sensing. Collision and data frames may be lost during the transmission of data through multiple stations. Okay, collision may occur by using this random access protocol, but there is an advantages by using an access protocol. Here the main important thing is collisions occur, but we are not indicating this collision occurred in the between the channel. Nobody is indicating whether the frame sent or received, we can't tell. But here Aloha process, whenever the collision occurs, here acknowledgement of the frames exist in Aloha. Acknowledgement of the frames exist in Aloha. Whenever the sender transmits the data from source to destination, if the frame is transmitted successfully to the receiver give acknowledgement to the sender. The receiver give acknowledgement to the sender. That process will be available in Aloha. Okay, and there is no, whenever the collision occurs, there is no collision detection process. It is a first random access protocol. So in this, two to reduce that only the acknowledgement process is appeared in this particular random access protocol, it requires retransmission of data after some random amount of time. So here the retransmission of data will be there, some random amount of time will be wait, after that it retransmit the original frame, because the acknowledgement is not exist to the particular sender, not because the frame does not received by the receiver does not give an acknowledgement to the sender. Here there is a collision occur in the channel while transmitting the data from source to destination. The sender will identify that, it will wait for the sender wait for some random amount of time for acknowledgement. If the acknowledgement doesn't receive by an sender, again the retransmission of data will be done by the sender. The retransmission of the data will be sent by the sender. Will be done by an sender. Okay, these are the rules of an Aloha, and these Aloha again divided into two types. See, Aloha is divided into two types: pure Aloha, slotted Aloha. Pure Aloha, slotted Aloha. Okay, so what is the what is the purpose of an pure Aloha and purpose of an slotted Aloha? We discussed in this. Let us get into the pure Aloha. Okay, so what is meant by pure Aloha? Whenever data is available for sending over a channel at a stations, we use pure Aloha. So here in this type of Aloha, what is the rules we have? Some rules already Aloha put in some rules. In this pure Aloha, what it will follow? See, in this pure Aloha, when each station transmits data to a channel, without checking whether the channel is idle or not. Here, not sensing the channel. In this, not sensing the channel, it does not checking the channel state whether it is an ideal or working. Okay, each station can transmit the data without checking whether the channel is ideal or not. That is the first thing. The chances of collision may occur. Definitely the chances of collisions may occur, and the data frame can be lost. When any station transmits the data, frame to a channel, the pure Aloha waits for the receiver's acknowledgement. So this is a pure Aloha acknowledgement. If it does not acknowledge the receiver end within the specified time, the station waits for a random amount of time called the back of time. So here waiting for an acknowledgement by the receiver, thus time will be calculated by thus time will be called it as the back of time in the TB, back of time, we call it as TB. And the station may assume the frame has been lost or destroyed. Therefore, it retransmits the frame until all the data was successfully transmitted to the receiver. Here, one thing is there. Whenever the data frame is sent by source to destination by using this channel, and this pure Aloha, after sending the frame, it receives an acknowledgement of that frame. Then only the next frame will be sent to the channel. If the particular sender doesn't receive any acknowledgement by the receiver, okay, it will wait for a random amount of time for acknowledgement. Okay, that time will be called as a back of time, whatever. Acknowledge, he waits for a random amount of time for acknowledgement. In this time also, the particular sender doesn't receive any acknowledgement. The sender identifies this the particular frame has been destroyed or lost. Again, it retransmits the first frame. It does not go for a second frame, next frame. It retransmits the first frame. It successfully delivered to the receiver, and that particular acknowledgement will be received by the sender. Then only the sender get into the next frame to deliver the next frame. So that is the concept of pure Aloha. So in this, what is the disadvantages means does not sense the channel whether it is ideal or not. Number of users can use this channel to transmit the data or to communicate data from source to destination. Right. So this is an actual diagram. I will show you. Okay, see, this is an actual diagram in Big Banana. I'll show you. So I think it is visible. Okay, this is on station 1 and this is on station 2. This is on station 3. This is on station 4. Okay, so here one channel is using. Okay, station 1 sends and a frame 1.1. First he sends and frame 1.3, 1.2, 1.1, frame 2.1. Number of users are sending the frames at a time. See, these are the frames. Okay, but whenever sending the frames, definitely receive the acknowledgement by the receiver each and every frame. Then only the next frame will be sent. Whenever the successfully the frame is received by a receiver, he give an acknowledgement to a particular sender. Then the sender transmit the second frame in the channel. Okay, so here collision will occur. See, this is an only one channel. Collision duration. See this collision duration. Okay, see the collision duration. So the frame 1.2, 2.1, 2.1 will get collide, I think so. Next. So this is a number of stations are using a single channel. This is a collision duration. The frames will be collide. Okay, at a time. So this is the process of pure Aloha. So it does not sense the channel. It does not sense the channel whether the channel is idle or busy. Number of stations transmit the data at a simultaneous manner, right? Okay, to avoid this type of a disadvantage, we introduce another thing is an slotted Aloha. So the slotted Aloha is designed to overcome the pure Aloha's efficiency. Pure Aloha's efficiency. Pure Aloha is efficiency manner, but there is one disadvantage. This does not sense the channel. It will not wait. It will not wait for some time to transmit the frame from source to destination. Does not send the channel whether the channel is idle or busy. So definitely the collision will occur. To overcome that pure Aloha's efficiency, okay, here the pure Aloha has a very high possibility of frame hitting, right? Because number of stations transmitting and data frames at the same time. Definitely the frame hitting will be high in pure Aloha. To overcome this, the slotted Aloha is introduced. The shared channel means what is the channel that will be shared by number of the users, that will be divided into a fixed time intervals, fixed time periods or fixed time intervals called slots. That's why the name comes slotted Aloha. Here, the one channel will be divided into fixed time of intervals called slots. So that's if a station wants to send a frame to a shared channel, the frame can only be sent at the beginning of the slot. Beginning of the slot. Okay, so he have to book the particular sender have to book the particular time beginning of the slot only. The if a sender wants to send some data frame to the channel at the beginning of the slot only, he transmits that particular data. Only one frame is allowed at to be sent at each and every slot. Whenever I book a one slot, 1 hour, okay, in that 1 hour I can transmit only one frame, and it will be sent to the channel at the beginning of the slot only. At the beginning of the slot only. And if the stations are unable to send data to the beginning of the slot, whenever the slot begins, the number of stations are unable to send the data, the station will have to wait until the beginning of the slot for the next time. So here one station book in one slot, beginning of the slot, he sends the frame. Number of stations are requesting to send our data by using that particular channel. Here the station will wait until the completion of that process, after it will be come back to the beginning of the position. At that time the next station will book that particular slot to communicate data frame from source to destination. And this is the diagram. See, this is a slotted Aloha. Okay, I will show you in big manner. Okay, I think it is visible. Okay, so this is a slotted Aloha. So I have a 4 stations using a same channel. Okay, this is the beginning of slotted. Okay, whenever I'm sending an station 1 book and slot, here first frame 1.2 is sending. Okay, at a slotted time, this is an another time to send another frame. So frame 1.2 is sending. Okay, after that the station 2 will allocate another, will book another slot to send their frame, to send its frame. Okay, after that time, after over that time, the station 2 book for an frame 2.2. Okay, that will be transmitted here. Here each and every station have to book a slot to transmit data frame through the channel. Okay, but each and every time slot only one data frame can be sent. Here station 3 also booking the slot, only one frame is sending. After completion of that, another slot it will go for in frame 3.1. So this is in collision duration. In this, the frame hitting is less when compared to pure Aloha. When compared to pure Aloha, in this the frames hitting is less. Why? Because each and every station that divide the channel into number of fixed time intervals. In that time only one frame will be sent from source to destination. Only one frame will be sent from source to destination. After completion that time, again it will go back to the beginning of the state, and the next station will send that next frame through that channel. So like that, we can erase this type of collisions and crosstalk for somewhat. We can reduce somewhat, right? We can reduce somewhat in this slotted Aloha. So the slotted Aloha is introduced to reduce the frame hitting. To reduce the frame hitting. That is the drawback of an pure Aloha. In pure Aloha, the frame hitting is very high because it does not sense the channel whether it is idle or busy. For that sake, each and every station transmitted that particular data frame simultaneously, and the frame hitting is very high and collisions also rise in that particular time. Okay, to reduce that, the slotted Aloha is introduced. The slots means it takes that, divide the particular channel into different time intervals, fixed time intervals. We can call it as slots. At one time interval we can send one data frame. So by using this concept, we can reduce the number of frame hitting concept or collision. We can reduce collision or crosstalk. And this is about an random access protocol Aloha. And we have to discuss the another important thing, and which is the very important concept in multiple access protocol is CSMA. And we also have a two type CSMA CD, collision detection and collision avoidance, in this also. Okay, I think this video is useful to you. Kindly like, share and subscribe Easy BTech for more videos. Okay, thank you.